Hello, this video is about creating your own do-it-yourself version of a through-line Terminator, such as this B and C type that I purchased on eBay. Works quite well. It's a 50 ohm through termination, but I had the need to use a SMA type through termination 50 ohm. I couldn't find anything available that was reasonably priced. There was one for $125, probably quite well made and good specs, but I only needed something that would be useful from 1 megahertz to 30 megahertz. So I came up with this little modification of two SMA PCB board type connectors. This is a male on one end, and this is a female on the other end. So what I did was I put them together using two 100 ohm SMD surface mount resistors, 1/8 watt each. And they're in parallel, so I came up with 50 ohms and a half watt. So that's sufficient for what I needed. There's a picture of the resistors, the SMD resistors. I had some helping hands. I put a little bit of glue, crazy glue type product that you can see in the picture. Just a tiniest dab on it. I mean, barely recognizable. And I was able to hold them in place, because these things will fly away if you're not careful. I was using tweezers, and they're very difficult to handle. And then I was able to solder them in, as you can see in this picture here. I put them in these jaw vices so that they're nicely aligned up, ready for soldering. So you have to solder the center pin connector and then these outer edge feet that usually are mounted in a PCB board. So that's what held it. And then there it is, all soldered in there. You can see the solder is on the outside. I did file those down so they're not round, they're more flat. You can see they're kind of rounded, the solder. So that's how that came out. So why did I need this? Well, I built these split toroid transformers so I could pick up coaxial currents running through the coax and to a meter that I built. I'm going to show you that in another video. I'll just briefly show you. It's this little meter here. I'm still working on it, and I call it a common mode current tester. So you can see it has these two leads on here that go up to my choke, isolation choke. And this is just a place where I test it. It's really supposed to be mounted outside by the antenna. So I test the incoming and then I test the outcoming at the same time using an AB switch, rather than this unit here that I use that only measures one side or the other, one at a time. This is a great little unit for, I call it the coax RF probe. But if you want to use something that you don't have to unclip and clip, this is what I'm working on right now. So, and then these terminate on the coax. So what I wanted was some 50 ohm terminators. So here it is right here, and it just plugs into here like this, and then my coax lead. So much for that. I wanted to test it to see on the nano VNA if there was any problems with it, or what it looked like on the nano VNA. Nano VNA here is all calibrated, so I won't go through those steps. So you can see right now that we're at the 50 ohm system impedance point right there. That's the system impedance point, defaulted for 50 ohms, and we're going from our stimulus from 1 megahertz to 30 megahertz. And you can see the SWR is flat as a pancake down here. What does it say? It's 1.021. And you can also see that there is no reactance at 50 ohms. It's pretty pure. Looks really good. So what I wanted to do was add a termination 50 ohms to this. Now when you put 50 ohms and 50 ohms, you got 50 ohms in here, 50 ohms here in parallel. That's going to come up 25 ohms, and it sure does. So we're looking at, instead of the 50 ohm system point, we have 25 ohms right here. And then if you notice that the SWR went up, well, I think what we got to do is we got to change something here. We got to change the system impedance point right here. It's defaulted to 50. Let's change it to 25 ohms and take another look at it here. So we're going to port Z, change it to 25 ohms. Now that is going to change our system, what we call the system impedance point, which was 50 ohms. Now you can see up here it says it's, well, let's see if it's in focus. Port Z was 50. It's set at 25 ohms now, and indeed it is. And now you can see we got the S standing wave is flat as a pancake again, 1.025. I did a test on the insertion loss, and I don't have it to show you here, but I wrote it down. It's I believe it was 3.55 dB S21 log mag insertion loss. So I'm happy with it, and I thought I'd share that with you folks here. And next video, I'll give you a little more information about what I'm working on in this project. It's going to be really useful. I really like this one here, this coax RF probe. It's been really helpful in chasing down common currents. And you can put these, you can connect these up to anything, like power wires, your power to your radios, power to audio cables, and when you transmit, you might see some RF floating around in all your wire. So with that, I'm going to say 73s, and yeah, if you want to build this, they're not hard to build, and they're cheap to build too. I think it costs, oh my goodness, they're $1, $2, $3, $4, maybe $5. I had to buy 200 surface mount resistors, 100 ohm, but what the heck, $7 for 200. So they're cheap to build. So with that, 73s, folks, we'll talk to you on the next video.